All right, example 6. What is the solution to the system of equations 3x minus y minus 5 equals 0 and x squared plus y squared minus 25 equals 0? You'll notice that the top equation has only x and y both to the first power in different terms. That's what a linear equation looks like. That top equation would make a line if I tried to graph it. Right? There's no powers. X and y are being multiplied together. When you multiply x and y, it causes curvature. When you take x's and y's to power, it causes curvature. When x and y are just the first power in separate terms, it always creates a straight line. Okay, nothing else happening except for x and y are the first power. The bottom equation has x squareds and y squareds, and you'll notice it is just what I described a moment ago as the equation of a circle. It's a little bit less involved than the one I just did a moment ago, but notice both x and y are squared, same sign, same coefficient. That is actually a circle equation. Okay, I don't want to make you think this is the actual graph of this picture, but here's the possibilities of what could happen with a line in a circle. Your circle's here. Maybe the line looks like that. We're looking for where these two things cross. Where do these two things cross? They don't. That's one possibility. A second possibility is that this line just lies right on the edge of the circle. So it's tangent to the circle, meaning it touches in one spot. There's a possibility of exactly one answer to a problem like this. The third possibility is the line goes like that, and there's a possibility of two answers to the problem. Okay. Our task is to find the answer or answers to the problem, or identify that there isn't an answer. So if it looks like this, it's empty set. If it looks like this, there's exactly one answer. If it looks like this, there's exactly two answers. Now, one technique for doing this would be graph both things and see where they cross and identify the points of intersection. We'll call that the way we'll do if we can't figure out this other way. Okay, I don't like that way very well. The other way is much more accurate, in my opinion, easier, so we'll see. So here's the other way of doing it. The official name of this is a linear quadratic system. Linear because it's y's and x's to the first power, quadratic because y's and x's to the second power. It could be any type of quadratic form. It could be a parabola, circle, hyperbola, ellipse. We haven't dealt with a couple of those yet, but it doesn't matter what the quadratic structure is. This technique works all the time when you get a linear quadratic system. First thing I want to do, I want to take a linear term. It doesn't matter which one. My linear terms exactly are 3x, it's supposed to be a highlighter, 3x is a linear term and negative y is a linear term. Everything else is a quadratic term or a constant. So x to the first, y to the first represent linear terms. I want to take a linear term and get it to say that letter equals everything else. Now, when I'm doing that idea, I could either get this to say x equals or y equals. If I have a coefficient of 1 or negative 1, like in the y here, I don't have to divide by anything. So it's easier, if I'm trying to solve for either x or y, it's easier to solve for y because there's only a 1 in front of it, specifically a negative 1. If I solve for x, I'm going to first move those over, then I have to divide by 3, all of a sudden I get this fraction. If I solve for y, I'm not going to get a fraction. Most people don't like fractions as much as non-fractions, so I'm going to assume you guys are like that, right? So if I'm making the choice, I can solve for either x or y. I'm going to solve for y, so it looks like this. 3x minus y minus 5 equals 0. Now for me personally, if the x or y is negative like this, I'm going to move it to the other side. So 3x isn't moving, it stays positive. 5 isn't moving, it stays negative. Y does move, it becomes positive. And 0 plus y is y. And just like that, it says y equals something, right? That's my first step in a problem like this, a linear quadratic equation. I want to get either x equals or y equals the other thing. So y equals the other thing. Don't write this on your paper, just to show you why solving for x would be worse. The x term is positive, right? So if I have 3x, and again, don't write this because this will not be what we're doing. If I wanted to get this to say x equals, so first I'd move the y and the 5 over because this is positive. So 3x equals y plus 5. And all of a sudden I've got to divide by 3. That's what x equals. So I have a choice of getting y equals this nice friendly looking expression like this, with no fractions in it, or x equals this ugly fraction equation. They're both correct, both will work, both will get you the right answers. This is much more difficult to work with. This is much easier to work with. So again, coefficient of 1 is your best friend in a problem like this. If there is no coefficient of 1, you're just going to have to deal with a fraction expression like that. There's no way to avoid it. All right? So, once we've taken the linear term from the top equation to get it to say y equals everything else, what we're going to use is the fact that y is equal to this. Y is the same as this, and there's a y in the other equation. So I'm going to do a substitution. I'm going to replace that y over there, highlighted y, with the expression that y equals 3x minus 5. It looks like this when I do it. X squared plus parentheses 3x minus 5 squared minus 25 equals 0. Take a moment to digest that step. That's probably the most important step in the whole problem. It changes a x and y equation into just an x equation. Just an x equation can be solved using general algebra 1 techniques, where an x and a y equation has infinity answers. This has 1 or 2 answers or 0 answers. So, again, the 3 possibilities we looked at. All right. Notice that I did replace a single object y with 2 objects 3x minus 5. So when I substituted y out, I put parentheses around my substitution. Y was being squared, 3x minus 5 is being squared. So make sure that that's like that. So now when I actually simplify this, 2 ways to do 3x minus 5 squared. We've seen this structure a lot. We dealt with it earlier this year. You would have seen it last year in Algebra 1, or 2 years ago in Algebra 1. Last year somewhat in geometry. But when you have a binomial squared, 2 ways to simplify it. Way number 1 is the shortcut way, which is the way I'd like you to do it. You square both pieces. 3x times 3x is 9x squared. Negative 5 times negative 5 is positive 25. The middle term is twice the product of these two things. Sign matters. So 3x times negative 5 is negative 15x. Twice that is negative 30x. If you want to have something you can see with your own eyes, as far as how to get that exact number right there every single time, this isn't really what's happening, but sometimes people need to see things with their eyes to believe it. All you're doing to get this number right here is you multiply this times this times this. Again, that's not really what's happening, but everything's sitting on your paper staring you right in the face. If you just multiply those 3 things, sign matters. 1 negative makes a negative. 3 times 5 times 2 is 30x. So 30x minus 30x. All right? That's how you square a binomial. That technique works every time, and this structure happens tons. So knowing that is helpful. Alternative idea, if you don't like that, if that's like, yeah, that sort of kind of makes sense, but I'm not quite sure I want to do it that way. Alternate technique is to do 3x minus 5 times itself. That is exactly what 3x minus 5 squared means. Then you're just doing FOIL. 3x times 3x makes 9x squared. This is negative 15x. This is also negative 15x, which adds up to make negative 30x. And that's positive 25. If you look at the FOIL versus what I did here, why it works, FOIL is just 3x times itself, which is just the first thing squared. The L part of FOIL is negative 5 times itself, which is just the second thing squared, right? The outside product multiplies these 2 things together once. The inside multiplies them together a second time, so we get the product twice. That's why it works. That's the shortcut. That's how the shortcut came to be. Again, if this doesn't make sense, FOIL still works. But again, make sure that this means that times itself, so you have to FOIL it. All right? So altogether, this structure here is x squared plus 9x squared minus 30x plus 25 minus 25 equals 0. If I combine like terms, I got 2x squared terms, I got 2 numerical terms, and I got one linear term, right? So I've got 10x squared minus 30x And then 25 minus 25 makes 0, so equals 0. Our final step to find x is to solve this quadratic equation. You'll notice there is no constant term, there's only a quadratic and linear term. So when that happens, we have a common factor. So x goes into both things, obviously, but can we see that 10 also does? All right, so if I take my common factor of 10x, get 10x times x minus 3 is equal to 0. 10x squared divided by 10x is x. Negative 30x divided by 10x is negative 3. And then I go to zero product property. Either factor 1, 10x equals 0, or factor 2, x minus 3 is equal to 0. So we go from a quadratic second power equation into two simple linear equations. If 10x equals 0, how do I find x? Divide by 10. What is 0 divided by 10? 0. If x minus 3 equals 0, how do I solve for x? X minus 3 equals 0.
Add 3 to both.
Add 3 to both sides, or move the 3 across, change the sign, take your pick. So if I chop the 3, make it plus 3 on this side, 0 plus 3 is 3. So x is equal to 0 and 3. Now, we're supposed to find ordered pairs. An ordered pair is a grouping of an x and a y on the coordinate plane. And the values that I just got says x equals, right? And be very careful with these problems. There's an x and a y in it. I changed y to x. Now everything's about x. So down here, I didn't just write 0 and 3. I wrote x equals 0 and 3. Make sure you're not abandoning variables in your work, that they're showing up all the way through the process. X equals 0 and 3. I need to find x and y. So again, we had 3 possibilities. No answers, 1 answer, or 2 answers. I got 2 answers for x, which implies I'm going to get 2 answers for y, which means I'm going to get 2 points of intersection. So if x equals 0 and y equals 3x minus 5, and I'm taking this answer here, x equals 0. This says what y equals up here. I'm going to replace x with 0 with another simple substitution. 3 times 0 is 0, 0 minus 5 is negative 5. So x of 0 goes in, y of negative 5 comes out. 0, negative 5 is a point of intersection of the line and the circle. My second answer is x equals 3. So x equals 3, x equals 3, y equals 3x minus 5. Again, I just go back here both times. That says how y and x relate. I know what x equals. I change x to that number, so x equals 3 goes right where x would have been. 3 times 3 is 9, 9 minus 5 is 4, so 3 comma 4 is the other answer to the problem. So again, we're looking for x, y ordered pairs, find both of them. More often than not, there's 2 points of intersection in these problems. One last thing I want to bring to your attention before you do the homework associated with this, because again, I didn't make these problems up, I just pulled them out of the book. There's a little section of problems. Couple things that might happen and how to handle it. Okay. Suppose we got to this point here, and it's 10x squared minus 30x plus 7 equals 0. Now it's not got a common factor. Now we got to look at how do we factor this thing. So here's the scenario. I do one of these problems, I end up here, x squared, let's say 5x squared minus 9x plus 2 equals 0. Suppose I get there. All right. I have to factor this thing, but it factors very difficultly because there's a number in front of x squared. The better option, if you can't figure out how to factor it, is to go quadratic formula. We've seen this. That's what the quadratic formula says. I would write it on my paper if I were you. So again, if you get to a quadratic structure equals 0, it has to have that exact structure. X squared, x, constant equals 0. It could be y squared, y, constant equals 0. It doesn't matter what letter it is, just a squared object, squared letter, first power letter, and a constant equals 0. Okay. This is the answer to the problem, whatever the letter is. If this said 5y squared minus 9y plus 2 equals 0, now this says y equals instead of x equals. So again, it's solving the problem for whatever letter's in the problem. All right. If you break the quadratic formula down into these three pieces, it's this piece, and this piece. The green part is the hard part, if there's any hard part at all. Okay. Minus b is easy, 2a is easy, b squared minus 4ac is not hard, but it's not easy, so it's sorting between hard and easy. So the a, b, and c in the formula relate to the coefficients of this problem. A is this, b is this, c is this. Sign matters. So a is equal to positive 5, b is equal to negative 9, c is equal to positive 2. So make sure that the signs are included in your work. Don't just write 5, 9, 2. 5, negative 9, 2. Okay, next, minus b just means whatever b is, here's b, it means whatever b is, change the sign. If b is negative, minus b will be positive. If b is positive, minus b will be negative. Minus b just means whatever b is, change the sign of b. 2a means you look at a up here and just double it. Whatever a is, you make it 2 times as big. 2 times 5 is? 10. Okay? That's not going to be the hardest question to ask today. All right, the final one. B squared minus 4ac. Now, this is the one that does mess people up a little bit, so I'm going to throw a couple highlights in here so you won't hopefully mess up. The most common mistake is just some sign issues, and let me just show you the biggest sign issue that happens. I got to go purple because I ran out of colors. B squared, no matter what b's value is a positive number. Negative 9 times negative 9 makes positive 81. Positive 9 times positive 9 is positive 81. You're squaring whatever b is. That includes squaring the sign and the number. So no matter what b is, ignore the sign, just take it times itself. 9 times 9 is 81. Okay. I don't even write on my paper 9 squared or negative 9 squared. I just, in my head, 9 squared is 81. I just write it down. I know that's always positive. Minus 4 times a times c. A is whatever a is, and c is whatever c is. And a is positive, c is positive. Signs do matter. If c were negative, I'd write a negative 2. If a were negative, I'd write a negative 5. So let the signs be what they are. Again, do that in your head, and then write down minus 4ac, whatever a and c are. Next, do the product. Now, this is always a minus sign here because the formula says minus. Okay? In the process of multiplication, if I end up multiplying enough negatives, I can change negatives into positives and positives into negatives, right? So how many minuses are in this product? 1, right? Odd number of minuses keeps it minus. If one of these numbers happen to be negative, now it's minus 4, positive 5, negative 2. All of a sudden now it's plus instead of minus. So again, the formula says minus, you write down minus, but then when you multiply, there's a possibility this changes to a plus. In this case, it doesn't happen. 4 times 5 is 20, times 2 is 40. 81 minus 40 is equal to 41. Finally, x equals. I'm going to create this structure right here, and I'm going to replace those 3 pieces there with the numbers they equal. So you figure out those 3 numbers over here, easy, easy, moderate, right? Figure out those 3 values and just create the structure of the quadratic formula. You just put your numbers where they belong. So 9 goes here, 41 goes there, and 10 goes there. The final step, I want you to get ordered pairs. It's hard to work with that as a numerical answer. Square root of 41 is not some pleasant number like 5 or 10 or something like that, right? So I'm going to grab a calculator now, and I'm going to type in square root of 41, get a decimal approximation to a couple decimal places. So 6.40. And I want to create 2 answers here. To get the 2 answers, 10 is the denominator of both answers. I need the numerators. So the plus or minus means to do 9 plus 6.40, and minus means 9 minus 6.40. Okay? Work it out. 9 plus 6.40 means 15.40. 9 minus 6.40 is 2.60. If I divide by 10, it just slides the decimal place over. So my answers for x are x is equal to positive 1.54 and positive 0.26. Now, my original problem was right here. I'm going to slide it over so my calculator can be on the screen at the same time. If I type in this, those are my x's, right? 5 times 1.54 squared minus 9 times 1.54 plus 2. This is supposed to be an answer to this problem, so the answer should be 0. I did round, so it's not exact, but it should be really close to 0. That's almost 0, right? If I got my 0.26, so it's 5 times 0.26 squared minus 9 times 0.26 plus 2. Again, 5x squared, x is 0.26, minus 9x, x is 0.26 plus 2. That should be around 0. Again, I rounded, so it won't be exactly right. They won't always necessarily be the exact same number like that, but they're both almost 0. Right? So that just demonstrates that that's how you do it. Okay? Anytime you can't factor, so you get to this step here, you're like, ooh, I don't know how to factor that. In this problem, A would be 10, B would be negative 30, C would be 0. C would be 0 on this one, and you can still use the quadratic formula. So if you get to this point, you're like, I don't know about factoring, you can always rely on the quadratic formula. And then once you get your x answers, again, I didn't have a whole problem up here, but once you get your x answers, you'd go back to your substitution to find out the y answers for that one to make your ordered pairs. So again, that'd be the most ridiculous thing that might happen in your homework that wasn't covered specifically with that last example. You might have to deal with the quadratic. If you don't know how to factor, the quadratic formula will get you the answers. Give me decimals if they aren't exact. All right?